Hello everyone, welcome back to another episode of Math Unlocked with your host, Mrs. Rhodes-Grierson. What are we doing today? Today we're looking at how to find the determinant of a 2x2 matrix. So if you're here, it means that you've started matrices already, you've watched some other videos, you've been in class, you've learned some things about matrices, you know that a matrix is a rectangular arrangement of rows and columns, and these elements are organized in rows and columns, and it should look like a set to you. You've been used to writing elements in brackets before, but this arrangement, and because it's a special arrangement, rows and columns, we call it a matrix. Now, there is a term called the determinant. Determinant. This is what will determine if a matrix is singular or non-singular. What do I mean by that? When we go into finding the inverse of a matrix, or to determine whether or not a matrix has an inverse, it's the determinant that tells us that. And our determinant is dependent on the diagonals of the matrix. I like all those these because it leads us into what we need to do. Determinant speaks about the diagonals. Remember that the diagonals are slant lines. So I'm going to call this my diagonal 1. This is my leading diagonal. And this is diagonal 2, my non-leading diagonal. Now how do I use this information to determine determinant? Using the determinant, this little symbol means the determinant of A. And find the determinant of matrix A. Now, to find the determinant of matrix A, I'm going to start off with diagonal 1, and I need the product of these elements. So I'm going to say 5 times 2, product means to multiply, minus. I'm going to end up with diagonal 2, and I also need the product of these elements, so that's 3 times 1. Going ahead now to simplify what is here, 5 times 2 is 10, minus, remember we do our multiplication before we do our subtraction at all times. So that's 5 times 2 is 10, 3 times 1 is 3. Simplifying this, we will get the number 7. What does this tell me about this matrix A up here? It tells me that matrix A is non-singular. It means that matrix A will have an inverse. When we get there, you will see how that translates into each other. But seeing that the result of the determinant is not 0, it means that the matrix I have here is a non-singular matrix. And any 2x2 matrix that you have, if you want to find its determinant, always first highlight your diagonals. Your leading diagonal comes first. Your non-leading diagonal comes second. You must have it in that order because the rule of subtraction, when it comes on to subtraction, the order matters. So you must ensure that diagonal 1 comes to the front and diagonal 2 goes to the back, so that when you do your subtraction, you get an accurate result. So the determinant of matrix A would have been 7. Try one for yourself. Let me leave you with one. What if I gave you matrix B, and matrix B has the numbers 3, 4, 2, 6. Can you find the determinant? And then will you be able to determine if matrix B is singular or non-singular? Try it out. Comment. Let me know.